All right, Owls, this is going to be the next video, or our first flip video for our new unit, Waves. Waves is a little tricky because there's a lot of new vocab. You just have to get familiar with the vocab and understand the differences within the vocab. So our flip video is just going to be about vocab. Not too exciting, but in order for you to effectively apply the knowledge of waves, you have to be able to know this vocab. And the best way to study for that would be a flashcard based thing that you just have to be able to know the word and know what it means and understand the differences between them. So let's get started. And then your Waves TOC, we'll do this in class, but it's going to be page number 3, Wave Key Vocab. And up there is the standard, just so you know I'm doing my job with following the standards. First word you need to know, let's start with what the topic is, waves. Waves transfer energy, also known as a disturbance, not matter, from one place to another. You can see why we do matter first, because we talked about in matter, everything is matter except for energy. And now we're going to talk about that other half, energy. A lot of people think they transfer matter from one place to another, but you have to understand all it's doing is taking energy from one place to another. This is going to get familiar with your 5th grade standards in force and motion and bring that back into a little different aspect. The next is known as a medium. No, I'm not talking about your shirt size. I am talking about any type of matter that waves travel through is known as a medium. This is why we do matter first, solid, liquid, gas, plasma. If energy is transferring through that would be known as a medium. And we'll talk about mediums in a variety of different ways as we move forward. This is the first thing that people get confused with. There are 2 types of waves, and there's also 2 types of wave movements. You have to understand the difference between the two. So when you talk about waves, waves can be one of 2 things. The first one they can be is mechanical. So mechanical is one of the 2 types of waves, and I emphasize the word types because you have to understand there's different things between types and wave movements. So these waves transfer energy through matter. Okay, so they need a medium. If they need a medium to travel, they're automatically mechanical. So these are the key information for mechanical waves. So one of the 2 types, mechanical. The next is electromagnetic. This is the other type of wave. So it's either a mechanical wave or electromagnetic wave. You cannot be both. You're one or the other. These waves transfer energy through a field or empty space, and they do not need a medium, the biggest difference, but they can use one. For example, light is a EM wave that can travel through space. Sound is a mechanical wave. It can't travel through space. There are 7 types of EM waves, and those 7 types are listed there: radio, microwave, infrared, visible light, ultraviolet, X-ray, and gamma. We'll talk a lot more about the EM waves. That's known as the EM spectrum right there. We'll talk about that more when we get later in the unit near the end when we talk about just EM waves. So like I said, there's 2 types of waves, but there is also 2 types of wave movements. Now these movements is how a wave travels. One of those 2 types of waves is known as a transverse wave. You can either be one movement or the other. You can't be both. So this is one of the 2 types of wave movements. Big difference between types of waves. The wave movement in which the energy travels perpendicular to the direction of the wave, meaning the energy is going up and down, but it's not moving along parallel. This can be both mechanical and EM. So transverse is special because it can be both types, and all EM waves travel as transverse wave movements. So not all mechanical waves do, but all EM waves do. The other type of wave movement is known as a longitudinal compressional wave. This is the other type of movement. Unlike the transverse wave, this energy travels alongside, parallel, or with the direction of the wave. And these are only found with mechanical waves. So if you know it's longitudinal, you know it's mechanical. Now, the next part of the vocab is understanding the different parts. Some, in the 2 different wave movements, some parts are unique and some parts are shared. So let's talk about the parts that are only in transverse waves. The first of which is a crest. The crest, not your toothpaste, but they named their company off of it, is part of a transverse wave movement. It is the highest point or peak of the wave. Crest named their company that way because they wanted to be the top of their company. So that it's the highest point or peak of the wave, just like the crest of a wave is the tip of a wave in the ocean. There's also a trough. The trough is the opposite. This is in transverse wave movement, and this is the opposite of a crest. It's the lowest part, or the valley of the wave. Now, there are some parts that are only for longitudinal compressional waves. First of which is known as a compression. This is where the wave got its name from. Part of a longitudinal wave only, and this is the part that's compressed or closer together. It's actually showing you how much energy the wave has. So the amount of energy is the compression. The bigger the compression, the bigger the power of the wave. This is why it's also known as the amplitude. So amplitude means how much power something has. Bigger compression, more amplitude. Smaller compression, less amplitude. Another part that's for longitudinal waves only is rarefaction. And this part of the wave is that it's stretched out, extended, or expanded out. And what it means, it's showing you how the energy is being released in the wave. So the bigger the amplitude, typically the bigger the rarefaction, because the release of energy would take longer. And the smaller the amplitude or compression, the smaller the rarefaction, because it's less energy. There's also some parts found in both of these types of wave movements. The first of which is amplitude. You heard me talk about it in compressional waves, because compression is also known as amplitude. But it's found in both of the wave movements. To identify it in a transverse wave, it's the distance from the resting center line of the wave to the tip of the crest or the trough, which is actually the same exact distance. And in the longitudinal wave, it's the measurement of one full compression. Don't get worried about labeling these. We will do this in class together so you can see it. It'll make more sense when we draw it out and make models of it. The next thing that's shared in both wave movements is known as a wavelength. In a transverse wave, you'd measure it by finding the distance from one crest to the very next crest, or one trough to the very next trough. We'll talk about more of that in class, so it'll make a little bit more sense to you. And in longitudinal waves, it's the measurement of one compression and rarefaction together, meaning the beginning of a compression to the end of the rarefaction. It can also be vice versa, meaning the beginning of a rarefaction to the end of the next compression. We will also talk about that in class, so don't get nervous if this doesn't make sense to you. And frequency is the number of wavelengths that pass a given point of time over a given period of time. It's usually 1 second. We use frequency a lot with sound, and that's something we'll be learning about in this unit. Frequency and wavelength are directly related, and what I mean by that is this next bullet. So as one goes up, the other one will go down, meaning a high frequency wave will have short wavelengths because it's happening more often. But a low frequency wave would have very long wavelengths because it's happening less often. And these are used in both of the movements. I know this is a lot of vocab. However, we have to start this way for you to understand this unit. You have to be familiar with these words. I honestly recommend making flashcards. That is an old school way, but in this case, it's a very useful way. Remember, we'll be drawing these in class to make a little bit more sense of them, but you have to understand what they mean. All right, any questions, write them down, and I'll happily answer them when we talk about the notes in class together. All right, take care.